Okay, so the easiest way for me to find electron configurations is by drawing out an electron configuration map. So basically, look at the periodic table. Well, I already just know how to do it by heart. It's so that took me, I don't know, about 45 seconds to a minute to draw. So I'll show you how to do it. So basically, this electron configuration map is the periodic table in a nutshell. So with the electron configuration map, what I did was I first listed out 1 through 7. These numbers represent the rows on the periodic table for groups. So we have 1 row, 2 row, 3 row, 4 row, 5 row, 6 row, 7 row. So there are 7 rows on the periodic table. These ones do not count because they insert to here. So if we were to put the periodic table in numerical order, we would have 7 rows total. So that's what these 7 rows represent. Now, this is your S block. This is your P block. Well, let me zoom out. This is your P block. This is your D block. Your metals are your D block. And then this is your F block. So basically, this helium belongs over here. Like I said, if it was in numerical order, then the helium would be right here, which is why it's a part of the S. So we have S, P, D, and F. So if we count the S block, we have a total of 2 periods or 2 columns. So what that means is the S orbital is capable of holding up to 2 electrons. So if we look here, we're just going to label 2 electrons for the S orbital. And for rows 1 through 7, we can say that they all have an S, right? Because as soon as I go over here, there's no S on the second, on the first, I'm sorry, there's no P on the first, it's only S because of the 1 and the 2. So then the next row, now we have the S block and the P block, right, are involved. So we know that P has a total of 1, 2, 3, 4, 5, 6 periods. So that tells us it can hold up to 6 electrons. So also it starts on row 2, like we said. So 2, 3, 4, 5, 6, 7. So the P block can hold configuration for rows 2 through 7, and it can hold up to 6 electrons. So what we're going to do here is label 2 through 7 and P6. Then we go to the D block right here. We know that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so it can hold up to 10 electrons. Also, something to memorize is that the D block actually starts for the 3rd energy level. So here we would do 3, or it would count as 3, 4, 5, and 6. So 3, 4, 5, and 6. I'm not really sure the explanation, it's just something you have to memorize. That D starts at 3 and ends at 6. So now we look here, and something else that you have to memorize is that F starts at 4. So this is 4, and this is 5. And F has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 4F14 and 5F14. So we know that F can only have 2 because there's only 2 rows. D can only have 4 rows total because there's only 1, 2, 3, 4 rows. P can only have 5 because there's only 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Sorry, 6. I can't count. And then S can have 7. There's 1, 2, 3, 4, 5, 6, 7, and here there's 1, 2, 3, 4, 5, 6, 7. And then the P, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So this is going to be your electron configuration map. Now, something that makes things easier is if you cross and count the number of electrons. So basically, when you cross, you do it going downwards at an angle. So this is your 2 electrons. This makes 4 electrons, because 2 plus 2 is 4. So 2 plus 2 is 4, plus 6 is 10, plus 2 makes 12. Okay, so then we're starting here. So we're crossing out 3p6 and 4s2. So 12 plus 6 is 18, plus 2 is 20. And then we're crossing out here. So 36, 38. And then 40, 10, 5p6, 6s2. We have 40, 56. And then we're doing 4F14, 5D, 6P, and 7. So that would be 56 plus 6 is going to give me 62, 64, 74 plus 14 makes 88. And then we're going to do 14, 10, and 6. This 14, this 10, and this 6 is going to give us 112 when you add it to the 88. So now if we pick an example from the periodic table, let's say they ask for the electron configuration of phosphorus, which is 15. So for phosphorus, we know that the atomic number represents the number of protons and the number of electrons, typically, usually. So for a ground state electron configuration, we're just going to use our map and add it to 15. We have 12 here, so we just need 3 more. And remember that you can only go from here, you can only go from up to down. So kind of like reading books, so from up to down, 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 up to down. So this is 12, so now we're going back up. We only need 3 more. So from the 6, we're going to subtract 3. So then you copy everything down. So you have 1s2, 2s2, and you go back up, right? Because you're going from up to down. So 2p6, 3s2, and then 3p3 would be the electron configuration. We can also shorthand it and say that phosphorus, the noble gas that is immediately before phosphorus, which 15, 14, 13, 12, 11, 10, is neon. So literally just look at the noble gas in the row above. So above the noble gas, it's going to be neon. So the shorthand for neon, you would put them in brackets. And then neon, we can say stops at 2p6. Or I can count it here. So 2, 4, plus 6 is 10. So this is where neon stops. So we need 5 more because phosphorus is 15. So we'd say 3s2 and then 3p3. And that's the shorthanded version. Now another thing to keep in mind is something like gold. Gold is element number 79, which is right here. So for gold, let's add up to 79. So we know that this is larger than 79 and this is smaller than 79. So we're going to get a configuration in the middle of these. So we're going to take 88 electrons and subtract it from 79. I don't know that by heart, so it's 9. So 88 minus 9 is going to give us 79. So we go here and we count backwards. So we have 2 plus 6 is 8 minus 1 is going to give us 9. So this minus 1 is going to give us our 79. So when you subtract the electrons from the atomic number, you'll get the number that you need to subtract from the electron. Does that make sense? So 9 minus 8. So this is 88. So minus 2 is going to give you 86. Minus 6 is going to give you 80. Minus 1 from the D10 is going to give you 9. So if you wrote it out, the electron configuration, which I'll label as EC, for gold, it's going to equal 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d9. Okay, so I just redrew the configuration here. I'm using the same scratch paper. But anyways, so basically, this is where it gets tricky. So you just got to pay attention to the electron configuration. So like for gold, I wrote it in order. So you see like how the first shell is complete because S, we have all 2. On the second level, we have all 2 in the S, all 6 in the P. In the third level, we have all 2 of the S, all 6 of the P, all 10 of the D. In the 4, we have all 2 of the S, all 6 of the P, all 10 of the D. Of the 5, we have all 2 of the S, all 6 of the P, but we only have 9 of the D. I realize I did not write this in order, but this should be up here, you get the point. So this for 5d10, or should be 5d10, right? Because 10 is the maximum that we can get out of a d orbital, but we only have 9. So in this 5th level, we have an incomplete d orbital, but then we move to 6. So basically how it works, we have 1, 2, 3, 4, 5, 6, 6s2, and then we have 2p. This is very, very, very shorthanded. So 2p, 2, 3, 4, 5, and then we have this. So we have all of our d's except for 1, right? So this is our d, 1, 2, 3, 4. This is our d, this is our p, this is our s. Ignore this because it doesn't matter. So this is our 5th row and this is our 6th row. So we're only looking at the 5th and 6th row. So we see that there's an empty electron here before we went up to the 6th. So in order for an electron configuration to be stable, we really want all of the energy levels filled. So in order to achieve this, the 6th level in the case of gold is going to donate. This is your S right here. This is S, this is P, this is D. So your S is going to donate an electron to here in order to make it more stable. All of the 5th level is full before we get to the 6th level. So your configuration here is actually 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10. I'm going to write it in order actually, so 4f14, and then 5s2, 5p6. So since we don't need any electron, this is going to be 5d10, 6s1. We can also shorthand it because we can say that gold is right here, right? So the noble gas immediately before gold is going to be xenon. So here we can shorthand it to xenon. And if we look on the periodic table, xenon, remember P starts at level 2. So 2, 3, 4, 5. And this is our P block. And we have 1, 2, 3, 4, 5, 6. So anything after 5p6, we're going to want to rewrite. So after 5p6, we're going to want to write up here. So because remember the 2, 3, 4, 5, the F starts at level 4, but it's still in row 6. So we have this 5, and then we're going to go through 6s1, remember, because the 6s donated an electron to row 5 of the D. So this is going to be row 5 for D, and then in here we have row 4 for 14. So you can legit just look on the map and say, so here, we're right here. So this 6s1 for D. So after 6s1, or after 5p6, right? Because this is where neon stops. So then it will be 6s1 because we donated 1 to the D, which this should be 9. So we still need to write the 4f14 and the 6s1. So then it would be 4f14, 5d10, and 6s1 would be the shorthanded version. So hopefully that makes sense.